This lesson continues from the previous one, where we discussed how to set up a new Firestore database. If you want to follow along with the examples, you'll need a basic Vue application with the Firebase SDK, as well as an empty Firestore database. In a Firestore database, data is stored in documents, which are organized into collections. Each document contains key-value pairs, where the keys are the names of the fields, and the values are the data you want to store. Documents can have a dynamic schema, which means that documents in the same collection don't necessarily need to have the same set of fields or structure. In Firestore, collections and documents are created automatically when you assign data to them. For example, if you have some data that you want to store in a document, you can specify the collection you want to store it in, and both will be created automatically if they don't already exist. We have multiple options to create a document, namely the addDoc and setDoc methods. The addDoc method automatically generates a unique ID, so we can use it when we don't have a meaningful name or ID for our document. The method takes two arguments. The first is a collection reference, and the second is an object of the data we want to store. The collection reference is a method that also takes two arguments. The first argument is the Firestore instance, and the second is a string name of the collection we want to store the data in. As an example, let's create a method in our root app component that adds some user details to a user's collection. We'll start by importing the Firestore instance that we created in the previous lesson, as well as the addDoc and collection methods. Then, inside a new createUser method, we'll get and store a collection called users. Because it doesn't exist right now, Firebase will automatically create it for us. Then we'll hardcode the object with the user details we want to store. This data would typically come from a form, like the ones we created in the input binding lesson. The final step is to create the document with addDoc. We'll also log the document's ID to the console for the demonstration. We'll run the method in the created lifecycle hook. If we run the example in the browser and take a look in the console, we'll see the generated ID. And if we open the database, we'll see the new collection with a single new document. Now, let's change the data to create another user. If we refresh the page in the browser, then head over to the database, we'll be able to see the new document. It's important to note though, that if we refresh the page with the same data, a third document will be created. The addDoc method doesn't overwrite documents that contain the same data. The setDoc method works almost the same as addDoc, except we need to specify a unique ID. The method takes two arguments. The first is a document reference, and the second is an object with the data we want to store. The document reference is also a method and takes three arguments. The first is the Firestore instance. The second is a string name of the collection we want to store the data in. The third argument is a unique document ID or name. As an example, let's change the method in our root app component to add countries to a countries collection. This time, we'll do everything in the setDoc method. If we run the example in the browser, then take a look in the database, we'll see the new collection and its document. Like before, if we change the data, then refresh the page in the browser, it'll create another document. But if we refresh the page with the same data, it'll overwrite the document instead of adding a separate one, unless we explicitly specify that we want to merge the data. To merge data into an existing document, we specify a third argument for the setDoc method. The argument is an options object with the merge key set to true. As an example, let's merge some new data with our GB document. If we run the example in the browser, then take a look at the database, we'll see the new entry. Although the documents in a collection typically have the same structure, it's not a requirement. For example, the capital entry in the GB document doesn't need to exist in the US one if we don't need it. This allows our database to be as lean as possible. To update existing data, we use the updateDoc method. The method takes two arguments. The first is the document reference, and the second is an object with the data we want to update. As an example, let's change the capital in our GB document. If we run the example in the browser, then take a look in the database, it will show the updated value. We can fetch a Firebase document with the getDoc method. The method takes a single argument, which is the reference of the document we want to get. The data is returned as an object and can be accessed with the data method. We can also use the exists method to check if the document we're trying to fetch actually exists. As an example, let's fetch our GB document and log its contents to the console. If we want to render the data to the template, we just assign them to local data properties. To fetch multiple Firebase documents, we use the getDocs method. The method takes a single argument, which is a query for the documents we want to fetch. The query is a method that takes two arguments. The first is the collection reference, and the second optional argument is a query filter method. As an example, let's fetch all the documents in the countries collection and render them to the page. We'll store the objects in a local array and loop over it in the template. If we run the example in the browser, it will show the countries with a capital if one exists for it. We can search for documents that match certain criteria. To do that, we use the where method as the query's second argument. The method takes three arguments. The first is the key we want to search. The second is the evaluation operator, and the third is the value we want to filter by. For example, let's say we want to find the country that has the capital Londinium. The key that we search in would be capital, the evaluation operator would be equality, and the value would be Londinium. To demonstrate, let's find all the people in our users collection that were born after 1990. If we run the example in the browser, it works as expected. The official documentation has a full list of evaluation operators. We'll leave a link in the description below. Firebase allows us to easily order documents by a field in ascending and descending order with the order by filter method. This method takes two arguments: the field to order by and the abbreviated order, like desk, for descending. The default order is ascending, so we can omit the argument completely if we want the results in ascending order. To demonstrate, let's fetch our two users and order them by their first names. If we take a look in the browser, we'll see Jane before John. We can also combine ordering with other filters like where. In that case, we simply separate them with a comma. To limit the number of documents that we fetch per query, we use the limit method. This method takes a single argument, which is the number of documents we want to limit by. To demonstrate, let's limit our users to show only one. It should be noted that the SDK has specific methods if you want to paginate data. We'll leave a link to them in the documentation, in the description below. To delete a Firebase document, we use deleteDoc. The method takes a single argument, which is the reference to the document we want to delete. As an example, let's delete the US document in the countries collection. If we run the example in the browser and take a look at the countries collection, the US document will be gone. If we want to delete individual fields, we have to specify the delete field method as a value for the key we want to delete in updateDoc. The method doesn't take any arguments. As an example, let's delete the capital field from the GB document in the countries collection. If we run the example in the browser, the capital field will be gone. Real-time listeners allow our apps to automatically update when data changes or gets added to the database. For example, let's say we have an app that shows the latest films available at the cinema in a user's area. If a user is viewing the list, while a new film is added, the page will automatically change to show the new film in the list. As an example of the default behavior, we have a button that adds the capital to our countries collection, then renders it to the template. If we run the example in the browser and click on the button, nothing will show for the capital. But if we take a look in the database, it exists. We'll have to refresh the page to see it. To register a real-time listener on a document, we use the onSnapshot method. The method takes 3 arguments. The first is a document reference, the second is a callback function that handles the data, and the third optional argument is a callback that handles errors. To demonstrate, we've changed the example to add an AKA when we click the button. If we head over to the browser and click the button, the text immediately updates with the new value. To register a real-time listener on a collection, we use a collection reference instead of a document reference. To demonstrate, we've changed the example to add a real-time listener to the user's collection and render them in the template. If we run the example in the browser, both users show. If we added another user, it would immediately update like the document example did. To register a real-time listener on the results of a query, we use a query instead of a document or collection reference. To demonstrate, we've changed the previous example to use a query that only returns users born after 1990. Remember that even though the listener doesn't need a collection reference, the query still does. If we run the example in the browser, the only user born after 1990 will show. The onSnapshot method returns a method that unsubscribes the listener. We can assign it to a constant and invoke it where we need. Alright, now that we know how to work with the database, we can learn about user accounts, authentication, and security in the next lesson. Thank you for watching. We'll see you in the next one.